2 is where we are finishing up. So you need to be in your notes, please. Okay. Oh, remind me. I forgot. Worry about it tomorrow. Cell phone caddies are set up back there, guys. Okay. I forgot to tell your class yesterday. I had them set up yesterday. So start tomorrow putting your cell phones in there at the beginning of the period. You have an assigned number. Okay. Enough said?
I'm still texting my mom.
Okay.
Like, what do you mean?
Get focused. Okay. Standard equation of a circle is what we were getting ready to talk about when the bell rang last yesterday. So standard equation of a circle is of this form. X minus h squared plus y minus k squared equals r squared. And the idea with this is that in this equation, the h and k form an ordered pair that represent the center of the circle. Okay, so h and k represent the center of the circle. So if the circle is centered at, say, 3, 5, then that means you move your circle over 3 up 5 for the center of the circle. And then r, what's r stand for in a circle? Yeah, r is the radius. Okay, so those are the pieces you need to know. So the idea is, and for example, a circle centered at the origin would look something like that. So the basic equation of a circle is x squared plus y squared equals r squared. And that's just a circle that is centered at 0, 0. It doesn't move left or right. It doesn't move up or down. Okay? You put the h and k in there, and that tells you how far you move your circle left or right, up or down. Okay? This is a good one to know, guys. You need to be familiar with this formula. Okay? We don't use it a lot, but it randomly pops up, and it's good to recognize. So here in example 4, it says find the standard form equation of the circle. So we're just writing the equation. If the center of the circle is 4, -1, and the radius is 8. So which pieces are they providing us? What letters do we fill in here for?
H and K.
Okay, so the center of the circle is h and k. So 4 is the h value, -1 is the k value. The radius, where am I going to put that in? That is your r value, correct? So take that standard equation of the circle and fill it in. Just like typical standard form equations, x and y are the variables, they stay. They're not going anywhere. So when I do this, I'm going to say x minus, what's my h value? 4. Quantity squared plus, and then it's y minus k, so this is going to be y minus -1, quantity squared, equals r squared. So that's going to equal 8 squared. At that point, it's a cleanup. Okay? X minus 4, quantity squared, is just going to stay. We just leave it in that standard form. What am I going to do about the y minus -1 quantity squared? Yeah, we can make that y plus 1 quantity squared. And you obviously could have done that right at the beginning. And 8 squared is 64. And so if you remember anything about algebra 2, okay, remember if it's x minus 4, if it's -4 in the parentheses, you're going to go opposite of the sign, right? So you go 4 right in the x direction. If it's y plus 1, it's in the parentheses, opposite direction of the sign. This one's in the y direction, so you're going to go down 1, which makes sense with the 4 -1. And radius is square root there. Questions on that? What about B? If the center is 0, 0, and the radius is 5. Thoughts on what that equation might look like?
Would it be x squared plus y squared equals 5 squared?
Okay. So you can kind of jump straight to the end, which is fine. X squared plus y squared, and he said equals 5 squared, which is going to be 25. And I am perfectly fine with you jumping right to that. Okay, that's perfectly fine for me. if you want to look at the longhand, I mean, officially, we can say x minus 0 quantity squared plus y minus 0 quantity squared equals 5 squared. That's kind of the long version, but once you guys see this and you're familiar with it, there's no reason to do that long version. Okay? Questions on this one? Again, just kind of lock this formula in your brain, get familiar with it. I mean, I introduced it to calculus I reintroduced it to calculus, and I'm kind of like, yeah, I kind of remember it. Again, it just randomly pops up. Okay, example 5. Write as an inequality. The distance between x and negative 3 is less than 9. So, distance. We talked about distance yesterday. What did we talk about with distance yesterday? Where was distance in our definition? And it wasn't a definition that's written down, but we talked about it.
Was it talking about finding the difference between the two different numbers?
No. Although, one of the distance values use what I need you to mention, or one of the distance formulas use.
So, the distance from 0.
Right, and distance from 0 was definition of absolute value, right? Okay, so when you see right there how it says the distance between x and negative 3, the easiest way to express that is to use what? Absolute value. Now, the distance between x and negative 3, so we're going to use x, and we're going to use negative 3. And someone mentioned the distance formula. Remember that distance formula that was the distance between 2 points? It was the absolute value of a minus b, right? So if you're trying to find the distance between 2 points, we're going to subtract them. So it's the absolute value of x minus negative 3. And then what else does it say?
It's less than 9.
Is less than 9. How do we do is less than 9? Less than simple and 9. Okay, so it's just a way to write an absolute value inequality. Obviously, you can clean that up, right? One small step. X minus negative 3 is the same as saying x plus 3. So I can say the absolute value of x plus 3 is less than 9. Okay. You'll see a few of those to practice in homework. I feel like there's some catch on some of them, but I don't remember off the top of my head, so we can look at that tomorrow if we need to. Example 6. There's kind of a 6a and a 6b. Use the Pythagorean theorem and the distance formula to show that the points, negative 3, 4, 1, 0, and 5, 4, determine a right triangle. Okay, so one thing I would encourage here is maybe a visual. So I know in my notes I kind of graphed a picture here, and then we'll talk about ideas on how this is going to work. So if I kind of graph a picture here, negative 3, 4, 1, 0, and 5, 4. Okay, that's just my random sketch. Does that look like it could maybe be a right triangle? Possibly. It's not out of the question, at least. How's that? Okay. Now, it said to use the Pythagorean theorem and distance formula. What do you know about the Pythagorean theorem? Okay. Pythagorean theorem is a squared plus b squared equals c squared. So the idea of a leg squared plus a leg squared has to equal the hypotenuse squared. So how can I use the Pythagorean theorem and the distance formula to show, because that's what we're trying to do here, We're trying to show that this is a right triangle. How do we do that?
You can get the distance between the points with the distance formula and use the Pythagorean theorem to see the length of each side.
Yeah, Pythagorean theorem, you have to know the length of each side, right? And if it makes the Pythagorean theorem true, it's going to be a right triangle. So we're going to have to know those three sides. So, here's what I would say. Pick 2 points to get yourself started. Doesn't matter. If I just pick, say, -3, 4, and 1, 0. Okay, do you remember your distance equation, distance formula? D equals the square root of, remember, x minus x, quantity squared. So I personally am going to say 1 minus -3 squared plus, since I did 1 minus -3, I'm doing 0 minus 4 quantity squared. That sounds familiar from yesterday, right? Do some math. 1 minus -3 is 4. 4 squared is 16. 0 minus 4 is -4. -4 squared is 16. 16 and 16 is 32. Honestly, I'm going to leave this as the square root of 32. We could go decimal if we want, but based on the fact when I put that number back in the Pythagorean theorem, I'm just going to have to square it again. It'll be easier to square it if it's in this form. So that's my reasoning for leaving it like it is. Okay, now what? Pick a couple new points. Doesn't really matter which. We're going to have to do them all. So if I use 1, 0, and 5, 4. So D equals the square root of, as I said, 1, 0, and 5, 4. I'm going to say 5 minus 1, quantity squared, plus 4 minus 0, quantity squared. 5 minus 1 is 4. 4 squared is 16. 4 minus 0 is 4. 4 squared is 16. And 16 and 16 again is 32. So square root of 32. One more. I don't know what can work and don't work here. So now I have to use what? -3, 4, and 5, 4. Could we shortcut this one? -3, 4, and 5, 4. Can you figure out how far apart those are without the big old distance formula? Yes? No? If we go left 3, up 4, and we go right 5, up 4. How far apart are they? What? 8? Because they're both 4 up, aren't they? So if you go left 3 and right 5, that is 8 apart. Okay? Now, if you didn't catch that, could you use the distance formula? Definitely. And I'll just write it out real quick to show you it does work. 5, 4, -3, 4. So I'm doing 5 minus -3 squared plus 4 minus 4 squared. So right there, 5 minus -3 is going to be 8. 8 squared is 64. 4 minus 4 is 0. So square root of 64, which is 8. Okay, so you could have figured that out in a shortcut. Now, how do I show, because that was my goal, show that this is a right triangle? Yeah. Plug these 3 numbers into the Pythagorean theorem. Now, the 2 legs are the square root of 32. It's a shorter size, right? And so 32 is shorter than square root of 60. So right here I'm doing a squared. I'm going to do square root of 32 quantity squared, plus square root of 32, quantity squared, equals 8 squared. Or if you prefer, square root of 64 squared. So what happens when you square a square root? Yeah, it's not a square root. So 32 plus 32, which is 64, which just so happens to equal 8 squared. So, is this a right triangle?
Yes.
Yeah. Because my Pythagorean theorem worked out to be true, this is a right triangle. So this is my proof. It is a right triangle. Okay, that is my proof it is a right triangle. Okay. Now, we have one more problem. And this says, use the fact that the diagonals of a parallelogram bisect each other to determine whether these given points make a parallelogram. What does it mean to bisect something? What?
Look inside.
Cut it open. Cut it how, though? Through the middle, right? Bisect specifically means to cut something in half. Okay, if we're going to bisect, we're specifically cutting it in half. So we want to know if the diagonals of the parallelogram bisect each other, okay, how can we use that to figure out, is this a parallelogram? Now, awkward on this one, they didn't give us numbers, did they? Good news is, believe the ones in homework, you have numbers, okay? But let's kind of make a visual here. I'm going to kind of do like a first quadrant graph, okay? Now notice what it says. The points, A, B. So a point AB, I'm going to go right A and up B. So there's a point, okay? We'll come back to this A plus C comma B one. Save it for the middle, okay? There's a point at 0, 0. You guys all know where 0, 0 is, right? And there's a point at C0. So C is going to be going over C, up or down 0. This other point is at A plus C, comma B. So if you go over the distance of A plus C, so you have to go over a distance of C and also add on